All right, hello, Jake. This is Chapter 3 review in Calc. So just to like make your day suck, you're gonna have to take a test over Trig Chapter 4 on Tuesday and a test over Calc Chapter 3 on Tuesday, because we'll review today and Monday and test on Tuesday in both of those classes. So sorry, that kind of sucks, but there's that. Okay. All right, we're gonna go through some of the review today. I am going to be gone for this class on Monday. Pray for me. I have like a big scan on Monday of baby to see if anything is wrong, and if we find out anything's wrong, we'll find out on Monday. So
and
if you get to thinking about it, we're not gonna find out, but we would find out on Monday if we did.
But it is a girl.
So if you get to thinking about it, just pray for me sometime between now and then. All right, there you go.
I will, and I will.
Great, awesome.
I'll thank God that it's a girl.
I don't know.
It's definitely a boy.
No, it is not.
All right, anyway.
A 0% chance it's a boy.
So Monday, I will leave the rest of this review for you in video format to watch. Make sure you watch it on Monday, because we'll test on Tuesday. Like, we can't put it off any more than that, otherwise we're going to cut into review time, okay? So test definitely on Tuesday, but I will leave any stuff for you on Monday that we don't get done on this review. So we got to get booking. Here we go. Chapter 3 review. Put up in the corner the order of which you do things. The very first thing that you're going to try to do when evaluating a limit is
Plug it in.
Plug it in. Plug it in. Okay?
Are we gonna be able to
Unless,
do
of
this
course,
on
I
the test?
give you the graph, like on number 1, you're not going to plug it. Well, you could try to plug the 5 in. You're not going to be successful. But if I give you the graph, you're most likely going to want to look at the graph. But you can try to plug in. That's always what you need to do first. Number 2, what shall you try to do next? Factor or divide, okay? So you can either do long division or you can factor it down. Factoring would be like when you have a difference of squares, or a simple trinomial. That's when I would factor it to see if it does something, okay? Specifically when you're factoring and dividing, you are looking for holes, and a hole will always have a limit. Always has a limit. A hole that divides out will always have a limit. Okay? A hole. A hole will always have a limit that you can divide out. Yeah? Good?
Yeah.
Number 3. You what?
I'm gonna have that now.
It keeps going out and in?
Yeah.
Like the signal?
Like the black screen.
Was that Mallory?
Yeah, for sure.
Okay, let's see if it does. Let's see if it fixes it. I won't move mine.
Oh.
Hold on, I'll quit moving it.
She's so
I'll quit moving it. Something's going on with my cord here. Okay, un momento, por favor. We gotta fix some stuff. Jake, fast forward.
Me, you, and Jack.
We don't even know who's in there.
Here we go. It's on the board.
Da, da, da,
Look,
da.
I'm
Can you
literally
see?
right here.
Okay, let's go. Here we go.
Okay.
Number 3.
I'm
What
not
do you do
saying
if
that
none of
you
those things work?
I'm just saying that your past record, I'm taking.
Okay,
into
pass.
consideration. You'll probably.
What's another strategy?
So I have to prove myself.
I have faith in you.
Okay.
Marcus, he really just gouged you, bro.
Kinda. I'm just saying that
Why is this happening?
That's fine. I like being doubted.
You'll
Okay, is it working?
Yes.
Okay, number 3 is rationalize. That's when you have a square root. Okay, you rationalize when you have a square root. And number 4 is look at the graph or the table. Okay, so you either graph it or make a table of values. Now, specifically when you're going to look at the graph, here are 2 graphs that you should know what they look like, right? You should know what 1 over x looks like. 1 over x is
the boomerang.
the boomerangy thing, okay? So if I give you like 1 over x plus 3, that's moved 3
Boomerang.
units, that's a boomerang.
To the right.
But that's moved 2 units or 3 units to the
Right.
And that's always the
Right.
left,
Left.
actually,
That's what I
right?
said.
Okay? So
That's
thinking about what the
always
graph of
the
that looks like, you can find the limit, okay? The other parent function that you should know is 1 over x squared.
Oh, what's that?
What is that?
It's a volcano.
It's the volcano,
I said volcano.
okay?
Not.
So if I give you
Can we use a
instead,
review on the test, please?
if I instead give you 1 over x plus
Sure.
3 squared,
You can answer that?
What?
Can we please use our review on the test?
it's gonna confuse you.
No, it's
If
not.
I say 1 over 3, or 1 over x plus 3 squared,
How is it gonna confuse me?
3 units to the left, and it looks like a volcano that way, okay? Yes, ma'am.
It
What if the number on top is like a 2? What does that do to the graph?
It only just makes it wider, like it makes this L more of a C instead, but it does not change your limit at all.
And if it's a negative?
And if it's a
flip it
negative,
upside
then it'll
down.
flip it upside down. So that will change it just slightly. Okay. So if this is a number other than 1, it's not going to change it unless it's negative. Then it's going to flip it down. Good question. Okay. So those are things that you should maybe already like know. The 1 over x and 1 over x squared. If you don't know that already, study it. Okay. Let's go through example 1. Here we go. We cannot successfully plug the 5 in. Do you know why?
Why?
0 on the bottom. We don't want 0 on the bottom. Okay. So we're looking at the limit as x goes to 5. Now, the limit as x goes to 5 means both sides together.
The limit does not exist.
Okay? If I say from the right, your limit would be 1, because that's a y-coordinate of 1. If I'm saying from the left, the y-coordinate would be negative 1. Agreed?
But they don't match.
So the limit as both sides together equals
DNE.
does not exist. If the limit does not exist, explain why.
Not the same.
Not the same.
Approaching 2 different values. They don't agree.
Can you put graph is not continuous?
No, because most of the time, like at limits, it's not continuous. So non-continuous places would be like a hole. A hole is not continuous,
So
but it still
graph
has a
is
limit.
not.
So it's approaching 2 different values, left and right. Okay, they're not in agreement with each other. So which one do you go with? You don't. You don't have to choose. It does not exist. Got it? Okay,
Well,
this is a piecewise function. This is a piecewise function. Okay, if there's going to be places that do not agree or that are going to have funny business happening, it's going to be at
The
Middle
2
one.
and
2 or it's going to be at
4.
4. Those are going to be the places where it's going to poop out if it does, right? Okay. So again, limit is the y-coordinate. So this is saying what is the y-coordinate as it approaches 2 from the left, okay? Which equation is going to be 2 from the left? The top one. What's that y-coordinate going to be?
It points left.
4.
Oh, oops.
It's going to be 4. If you plug 2 in, that would be 2 squared, which is 4. Do you see how that works?
Yep.
The limit is asking for the y-coordinate. Okay, the other one is saying 2 from the right. Okay, which equation finds me 2 from the right? 8 minus 2x. We're plugging in what?
2.
2, okay? So that guy has 4 as its limit. Okay, now what if they say 2 in general, which means both sides together?
Does not exist.
How's come?
No.
No,
They're
it
both
does
4.
exist. Why?
It does not
This is
exist.
not going well for
They're
me.
both
I have
four.
no
It
idea
Does not
what's going
exist.
on.
It's divided.
I'm
You're
like,
right.
All right, so hold on. Give me like 2 seconds to catch Emma up. Here we go. Emma, this says 2 from the left. You got that?
Yeah.
This says 2 from the right. Okay, so
Yeah.
2 from the left would be the top equation because it's x less than 2, right?
Yeah.
Yeah? So we just plug 2 into that equation, we get 4, right?
Okay.
That's the limit. The limit is the
Yeah, 'cause
y
they're
coordinate,
neat.
okay?
Okay.
2 from the right is x's that are greater than 2, so we're plugging 2
Oh my
into
gosh,
this
the
equation.
limit's the y coordinate.
The limit is the y coordinate. Yep, you're just evaluating the
Oh
y
my
after you plug it in.
goodness.
Okay,
No.
now, if
Oh
I
my
combine
God.
those two, the left and the right side together, if I combine those two, what's the limit as x approaches 2 in general?
4.
4, because they're both in agreement, right? These two
Yep.
are the same, so the limit is 4. If
This
those two were
one's
if those two were different numbers, the limit would not exist,
yeah.
correct? Okay? So what we have going on here is we have an open circle and a closed circle on top of it. Like we have something like that going on, right? Where this limit is 4. It's touching 4, okay? All right, now let's go 4 from the left. Which equation is 4 from the left?
The middle.
The middle one, right? And we're plugging in 4, right? We're plugging 4 in, okay? If I plug 4 in, I get 0. This guy's y-coordinate should be 0, okay? If I go 4 from the right,
That's the only one.
that's the middle, that's the last one, right? X is greater than 4, so we go 4 from the right. This is the right side of 4. The y-coordinate would be 4 if you plug it in, right? So if I'm doing both sides together,
It does not exist.
one of them on the left side is saying that it's approaching 0. This one's saying it's approaching 4, like a y-coordinate of 4 up here, and this one's a y-coordinate of 0 down here. There's a huge gap between them. So how do I decide which one?
It's
Yes,
none.
it
You don't. Does not exist, right? They are not in agreement with each other on which one to do. Does that make sense?
What? Yes.
Just think a limit is always what the y-coordinate is, or what the y-coordinate should be, right? They're not in agreement, okay? Number 3, what strategy are you going to use?
Try to rationalize.
Rationalize.
First, you're going to try to plug it in. Can you plug it in?
Nope.
Nope.
No.
No, because you get 0 on the bottom. So we're probably going to try to rationalize because there's a square right here. So what do you multiply by?
The square root of x plus 3 plus 4.
Plus 4, and the square root of x plus 3 plus 4. Okay, there's that. All right, let's do the top. Let's FOIL the top. Boop. Okay, the square root of x plus 3 times the square root of x plus 3
X plus 3.
is just x plus 3. Okay, now, do you guys understand that this guy and this guy are going to cancel each other out?
Yeah.
Yes.
Right? Like the middle two pieces are going to cancel each other out.
Yep.
So all I have to worry about is
X plus 3 minus 16.
negative 4 times positive 4, which is minus 16, yeah?
Yep.
Okay? Now, if I simplify that top just real fast,
X
that
minus
is
13.
x minus 13. Okay, great. Now, the bottom. When I taught you how to do this, I said don't multiply the bottom out. We just have x minus 13 times that other junk, right? The square root of x
Nice
plus
to
3
know.
plus 4, right? Okay, now,
X
it's
plus
fancy.
3 plus 4.
It's fancy. What happens?
It cancels.
The
There's a
X
ball
minus
there.
13
There's
is
a
canceled
ball
there.
there.
Now there's a VA. There wasn't there was originally a VA there. Yeah, that's right.
Okay.
1 over
Okay.
that.
So,
Isn't that a
what
four?
I'm left with is 1 over the square root of x plus 3 plus 4. What?
Is it a bar or a whole X minus
So
13?
technically, okay, so it is canceling out, but it's only canceling out because we're rationalizing it. So it is technically a VA.
Okay.
Is it a VA?
So we would say not.
It
I
doesn't
don't
matter.
remember.
It
I
doesn't
don't
matter
remember.
anyways.
Anyway, it doesn't matter.
It doesn't matter.
It doesn't matter. You might. I don't know. Anyway, I'm confused now. Okay. So now what do?
Plug in.
Plug in the limit as x goes to 13. So we plug 13 in here. 13 plus 3 is 16. So I have the square root of 16 plus 4
1 over 8.
is 1 over 8. That's the limit. So if the limit existed,
What-
actually I think you might be right. It is a whole because a VA would go to infinity. So I think you are right. We do have a hole there.
plug it in.
Okay. So 1/8
What
is
makes
what the
a
y
VA
coordinate
again?
should be.
You said the bottom equals 0.
Yes.
Okay.
Yes, but the whole is the same way. So a whole is just a VA in disguise, right? A whole is the bottom equal to 0 as well, but it also is the top too.
Okay.
Like it appears on the top and the bottom, okay? All right, which is what we're gonna have here. Example 4, we're going 4 from the right, okay? Don't get bogged down by the right stuff. Don't worry about the right stuff. Don't worry about the right stuff, okay? Don't worry about the right. Let's just talk about 4. Can I plug the number 4 in? No.
It's a
Okay.
difference of squares though.
So, but the bottom is a difference of squares, all right? X minus 4 and x plus 4, right? And then the x minus 4's cancel, so I have 1 over x plus 4.
1
Now,
over 8.
The reason why I say it doesn't matter that that's 4 plus, that doesn't matter that it's 4 from the right, because it wouldn't matter if it was 4 from the right or 4 from the left. If I plug 4 in here, it's going to be 1/8, right? It doesn't matter that I'm going from the left or going from the right. Okay? So, don't get bogged down by the plus and minus. 4 from the left or 4 from the right, it's going to be 1/8. Okay? Good? Yes?
Yep.
Beautiful? Okay, this one. I can't plug 2 in,
But
No.
they cancel.
but they cancel. They cancel already, right? It cancels already. So 1 over x squared plus 4. Now can I plug it in?
No.
What?
No. Yes.
Yeah.
It's
Yes.
x squared plus 4.
So it'd be 8.
8.
And then it'd be
What the
0
heck?
over 8.
1/8.
No, it'd be 1 over 8.
Oh wait, I forgot we
Right, 'cause we
Why
cancel the
are
top.
they all the same?
Hey, look at that.
We're
There's
all
1/8.
1/8.
What? I don't know.
What?
Did you do that on purpose?
Yeah, sure.
Wow.
Sure. I have a question for you.
What?
What's that thing right there and why is it there?
Who's reading?
That thing on the wall.
This, I don't
Yeah.
know. I think it was an outlet that they closed on.
It probably had a hole there.
Yeah, I think there's a hole.
Okay. Stupid.
Ah, we're such math nerds. All right, number 6. The limit as x goes to 9 of f of x. So basically, if you want to get rid of this f of x is actually 12 minus x. That's the function, right?
12 minus 9.
12 minus,
3.
this is a plug-in
3.
one. This is just like a plug the dang thing in, right? The y coordinate is 3. Okay.
27.
G of x is x to the 3rd power. That is
7.
27. You're just plugging the darn thing in, okay? All right, how do you do g
Plug
composed
it
of
into
f
f of x and plug that into g of x.
Yeah, plug it into f of x, then plug that into g of
27.
x, okay?
So 27.
Nice. It is 27. Hey.
Hey!
Hey.
Discuss the community
Good.
of what the heck?
Discuss the continuity of f of x, okay? If it is not going to be continuous,
It's at 1.
it's going to happen at 1, right? So we have to decide if it's not going to be continuous, it's going to happen at 1. All right. I'm going to do a little rough sketch of what this thing kind of looks like, okay? if we're talking about x is less than 1, 1 lives right here. On the left side of 1, it's a linear function. That's 3x minus 2. So minus 2 and up 3 over 1, and he'll look something like this. That's what he'll look like, but he has an open circle there.
Not continuous.
Right?
It's not continuous.
Okay? All right, 0. This says at 1 exactly, his y coordinate is 0. So he has a dot right here. This is an open circle, and this is a dot. Okay? And then greater than 1, it's just x. Okay? Which is a linear function that looks like this, right?
Yep.
Not
Yeah.
Continuous.
But that's going to branch off from here, right?
Facts.
So we have these two pieces that are going on, and then there's a hole that it drops out, and it drops down to 0. Is that continuous or not continuous?
Not continuous.
Not continuous at 1.
Is there like an algebraic way to solve that, or you kind of just have to graph it?
Here's how I solve it. Ready? If I'm on a train, am I gonna go off the tracks at that point?
Yes.
Yes, because it's a hole. There's like a missing track there. Okay? So think of it as think of continuous as being like
So
you're
just
on a
grab it.
train, right? So if I have like a function that's doing this, right? Like let's say something like that. That's what my piecewise function looks like, and I put my train here, right? My train is going along. He's going to derail here because he has nothing left to go on, right? Same thing if he has like a circle, right? Like even though this piece is connected to this one, he has a circle right there, which means a missing track. So my train is going to derail at that point, right? Because he's missing a track. So think about it that way. If you have a train and he's moving along, is he going to derail at that point? And if he is, then he's not continuous at that point. That's kind of like, I said that the other day, and Marcus is like, you should use that. So I'm going to use it now. Okay.
Train thing.
The train thing, yeah.
All
so
right.
just think of it in terms of a train, okay? Now, if this dot would have been up here where it's filled in right there, then he would be continuous all the way throughout. He would not have any missing pieces. Yes, sir.
What type of train? Dinosaur train?
Oh, good heavens.
Comet
That was
Okay,
train?
Ah,
wait, I have a serious question.
Yes,
before-
ma'am.
So we're gonna finish. How far on this are we gonna get?
One more.
And I have a question. Is
Get to 11. Let's get to 11.
We have like 5 minutes.
Let's get to 11.
oh,
To
then
get as
let's
far
just
as
do
we can
one
get.
more.
What?
Then let's just do one more. I
Keep
forgot
going.
it's
Let's go. Let's
Friday.
go. Let's go.
Let's
Then I'm
just-
gonna have to record all that.
Yeah, it's fine.
Okay, number 8. Discuss the continuity of the composite function f composed of g of x. F composed of g of x. All right, so that means I'm plugging g of x into f of x. All right, so this guy goes into there.
That's kind of gross.
Yeah?
1 over x squared plus 4 minus 8.
1 over, in place of this x, I'm putting x squared minus, or is that a plus 4? X plus 4.
Yeah.
Yep. Minus 8. Okay,
Minus
so
8,
what does that
just
come
like
out to
that.
be?
X squared minus 4.
1 over x squared minus 4, okay? The 3 things that can make him not continuous, okay, when we're talking about continuity, right? The 3 things that could screw up him being continuous are holes, which are removable, by the way. Those are removable discontinuities, okay? A va, which is not removable, okay? Or a piecewise function that does not match up. We already just talked about a piecewise function, okay? So those 3 can make a function not continuous. Those 3 and those 3 things only.
And there's
okay?
nothing here that
So this
suggests
is
that.
what it looks like. This is what it looks like.
It
And when
has
we
a bar,
compose
what
the
do
one
you mean?
inside of the other, right?
Right.
So does this thing have a whole, a
Where?
va, or a piecewise function? It's not a piecewise function.
There's a va.
It's a va.
Does he
At
have a va?
At 2.
Va at where?
2.
At plus and minus 2.
At plus and minus 2. This is a different squares. X plus 2,
You're
x
wrong,
minus 2.
Mom.
Right? Yeah, so he's not going to be continuous. I cannot plug in 2 and negative 2. It's like, where is the domain pooping out, right? So x equals 2 and x equals negative 2 are going to be my places where he's not continuous. So I'm going to say not continuous at x equals 2 and x equals negative 2. Got it?
Yep, we have to be done.
Okay. All right, now, are any of those removable?
Nope, because there's nothing on the top.
No,
There's no
because that
holes.
would be a hole, right?
Yep.
These are both vertical asymptotes, so not continuous at those 2 places, none of which are removable. I don't think you had to say that, but anyway. Yes, ma'am.
You can only have a va if it's a fraction, right?
Yes, correct.
That's the only way to set equal to.
Yep,
One,
yep.
two,
It's only
three,
the bottom
four,
equal to
five,
0.
six,
You can
seven,
only have a hole if it's a fraction.
So,
Okay,
11
I see.
people in my
Yep,
family.
right. Okay, good. Are you guys okay with doing 9 through 16 in bonus?
Yeah.
In class, like when I record it, okay?
Yes.
And I'll ship it in. I'll put it on Classroom. So look for it on Classroom.
No.
Got it?
You can hit me in the eye and
Okay.
I can die.
All right.
Oh my god,
Goodbye.
my mom, I had a T-pen in my pocket.